This third proof by contradiction that we want to look at came from a website I found, and I ended up, on the back of this, you'll see, this is the website that I found online, and they had a bunch of problems that they wanted to practice. I don't know that all of them are good. I know that we haven't gotten to this yet, number 13. We're not to trig yet. I assume that this means that B is not divisible by K, but I'm not exactly sure what that notation is, so we need to, I'll Google that. And I don't know that all of these are good for IB. I found it online, but every year people ask for more practice problems. So here could be some. Okay, so this problem came from that section, or came from that website. So what we have here is this is an if-then statement. And so we're going to assume that if a squared is even, then a is odd. Okay, where a is an element of the integers. If a squared is even, I should include that. A is an element. That's an element of the integers. There you go. Then a is odd. So then what that tells us is that we can then say that since a is odd, we can say that a is equal to 2k plus 1 for k is an element, for k element of the integers. Okay, therefore, then a squared would be equal to 2k plus 1 squared Okay, and that shows us, sorry, I have to practice to get my confidence up. Sorry for the long pause. Which would then equal 4k squared plus, that's 2k, double it is 4k plus 1. Since this must be even and this must be even, and we add one more, this is odd. Thus proving that a squared is odd, which is a contradiction. So, contradiction. Okay, therefore, I guess I could have used the dots. Therefore, if a squared is even, for all a in the integers, I should say that, okay, for a element of the integers, then a must be even. Oh, sorry, you can't see all my work. Okay, so talking through that one more time, we assumed that if this were a case of, let me come over here. If I have, it's kind of like saying P implies Q. Well, what we said here is that we wanted to find, we did the opposite there. We were trying to say P implies not Q. And then we worked with this assumption and discovered that that we had a contradiction. We're saying we worked from here and got a contradiction. We actually got to not P, therefore saying that that it must be even. Is that how? Yes, that's how we do that. Now go practice so that you will get the confidence. Notice I've been teaching for a long time and I'm still having to practice. So good luck to you. Practice, practice, practice.